Good day, everyone, and once again, your favorite uncle is back. And once again, we'll be looking at statistics. I'm sure and I'm hoping that you've been really enjoying those videos that we've made on statistics thus far. And today we'll be looking at just standard deviation, actually measures of dispersion. Obviously, I'll touch a little bit on measures of central tendency. And in this case, I want you to please note that we are still committed to giving you good content. So if you haven't subscribed, please just make sure that you hit that subscribe button. And of course, once again, you can always get in touch with us. All our contact details are below. And by the way, please always like and share at the end of the lesson so that we can get that algorithm going, but also so that we can tell as many people to benefit from the content that we are producing. All right, so without any further ado, let's just get into our lesson. All right, now looking at the first thing, remember that in statistics we've got two things essentially. We've got what we called measures of central tendency. And of course, if you haven't watched our first video on statistics on the scatter plot, not scatter plot, rather, the 5-number summary, please just make sure that you watch that video first, right? So we talk about measures of central tendency. I'll just say measures of center. All right, so on those, remember we've got what we call the mode. Right, remember the mode is it's a data value that is most frequently observed. So say you look at your data and there's a number that keeps popping up, obviously that is what we call a mode in this case. So we also have what we call the median. Okay, so which means it's the middlemost value. Okay, so if you've got, let's say, numbers 1, 2, 3, 4, and 5, what would be a median in this case? It would be the number that is right in the middle, right? Of course, if you've got odd data, it would be the number that is in the middle. But suppose that we had an even numbered data set, right? So how would we get, in this case, our median? So you see that we've got two numbers now that are in the middle, right? So now what we would simply do is just add the 2. So it would be, our median would be 3 plus 4 divided by 2 in this case. So that would be 3.5. So that would be the number right here. That would be our median, right? So please remember that the median in this case is the number that is in the middlemost, okay? Right. How we normally determine the median in terms of the position, in terms of, the position of the data. Now, if you think about it, this would be at position number 1, number 2, and so on. So in this case, we say to get the median, you'll always take n plus 1. So if you've got 10 data points, it will always be then the number that is at position n plus 1 divided by 2. So in this case, if you had 10 data points, it would be the number that is at 10 plus 1 over 2. So in this case, it would be at position 5.5, okay? So it would be in the middle there. So if you had 9, you'd say 9 plus 1 divided by 2. In this case, it means the data set point that is at position 5. Okay, right. I don't want to dwell too much on that. Okay, but we also have the mean of the data, right? So how do we measure the mean, right? Remember, if I've got data points, in this case, I would always take the sum of my data, right, divided by the number of data points that I have, right? So say for argument's sake, we were taking we're taking just data, and we find that in our data we've got 1, we've got 5, we've got 6, we've got, let's say, 9, we've got 11, right? Okay, so these are data values. So what would we do? So this is To get the mean, we just simply say this is 1 plus 5 plus 6 plus 9 plus 11, and divided by the number of my data points, 1, 2, 3, 4, 5. So that would be divided by 5. That is how we would get the mean. So that tells us about the measures of central tendency, right? Now I want you to think about it. We also have now, which is what I want to dwell on a bit today, we've got measures of dispersion, meaning how widespread is our data, okay? Measures of dispersion, okay? Dispersion. Okay, so my spelling kind of disappears now and then. Okay, so measures of dispersion, in this case now we're talking about the range. Okay, now remember, when you take the range, you would always take the maximum value minus the minimum, right? So in this case, you'd always say to get the range, you take the maximum value minus the minimum value. That would be your range. Okay, and we've got what we call the standard deviation, which is where I want to go. Standard deviation. Okay, as I did say that my spelling sometimes just my mind plays tricks on me, right? Standard deviation, in this case, I'm going to talk about it just now. When we talk about the standard deviation, we want to actually find out, it's a number that helps us to determine how close or how widespread the values are from the data. Now, let me just make an example. Say for argument's sake, and I'm not going to necessarily take numbers per se, right? That you take, let's say this is your number line, and you're collecting data, and now this would be the mean of the data. Okay, let's say this is our mean. We've worked it out, right? Now, if all of your data points are around the mean, all right? So meaning that if you were to take your data points, you'd see that most of them are around the mean there, right? So in this case, it means that our standard deviation would be quite low, right? But now, say you've got data points, there's our mean, but you've got data points all over the place. There your data points are quite widespread in this case. So what happens? It means that in this particular case, you'd find that you've got quite a spread of data. So as a result, your standard deviation would be high, right? Now, I want you to please note, the higher the standard deviation, it tells you that your data is spread out. The lower that standard deviation value, all right, it tells you that your data values are surrounding your mean. Okay, right. Now, how do we measure standard deviation? Right, we have a formula that we use, okay, and our formula looks as follows. So to get the standard deviation, you take the square root of the sum, all right, you take the data value, right, minus, in this case, the mean, right, but you square that, okay, so this is to make up for the negative, okay, so divided by n, which is the number of data points, right? So in this case, in the data that we used, 1, 5, 9, and 11, 1, 5, 6, 9, and 11, what you do is you'd get the mean first, okay? So we were calculating, we were making an attempt to calculate the mean, all right? And then you take your first value, 1 minus the mean, 5 minus the mean, and so on. We're going to do an example just now, take an example just now. So in this case, just remember, so xi, that would be our data point, okay, so that's the value, our data point, okay, and remember that x bar is our mean, okay, so that's the mean, and of course, n is the number of data points that you have, okay, right. Now, of course, this is quite tedious, especially if you've got many data points. And so as a result, it would really take some doing, right? But what I would like for us to do is just look at how to calculate. We're going to take a value, right, some data points. I'm going to take very, very simple examples, okay, and then we're going to do some past exam examples at the end. All right, just before we get into the calculation, what I just wanted to show you is how to, go about using your calculator. It might be Casio, it might be, another brand of calculator. But remember, what you're going to do is to go to mode, right? You just press mode. And of course, you're going to have those options. You're going to pick option 2, which is the stats function, okay? It will bring you to this screen, all right, and then you're going to choose option number 1. Of course, it depends on the calculator there, okay? So that's one variable there, okay, and it will bring you to this part. So this is where now you're going to put in your data. Remember, when you put in your data, please remember to put the equal sign for you to put the next data point, right? Okay, so you'll keep putting in the equal sign. Now, once you finish with your data points, in this case, please remember to press AC so that you save that data, okay? So after doing that, you'll press second function or shift stat, that is number 1, option number 1 there, right? And then it will bring you to this screen where you now want to find out what the variance or the whatever it is that you want to find. So you're going to press option number 4 for variance. Remember, variance and standard deviation are somewhat related. I didn't mention that before, but I will mention it later. Right, and then in this case, it is option number 3. Of course, it depends on the calculator that you're using. Okay, so in my calculator, it's option number 3, and that is the one that you're going to pick for variance. And of course, it depends. If you wanted to find out what is the mean, you would have picked option number 2. All right, so please just remember that is how we're going to use our calculator. All right, now let's get into our example. All right, now let's take an example together. Right, so we're given data values there for class A and class B. They say physical science marks from 10 learners from 2 different classes are recorded, right? So what they want us to do firstly is to calculate the mean percentage from each class, and then to calculate and comment on the standard deviation, and finally to calculate how many learners from class A have a percentage that is 1 standard deviation from the mean. Right, so here are our data values. So we've got our data. So what we're going to do is firstly try and put our data in the calculator. Now, please remember, the calculator that I'm using is not necessarily a typical the one that you would have. All right, but the principle is still the same. Remember, we start by going to mode. We're going to choose stat, okay? You would have chosen for one variable there. Right, so I'm going to input the data values. Okay, let me just bring in the calculator this side. Okay, so I'm going to put in my data values. So we've got 52, so that's class A. And then you say equal to, you say 82. And equal to, you've got 93. Equal to, you've got 95. You've got 71. You've got 65. Okay, let's just bring it this side. So we've got 77. We've got 42. We've got 89. This is quite a brilliant class. And we've got 48. Okay, so those are all our data points, right? So now, please remember, now that you've got all your data points, remember to press AC to save them, all right? And then what we're going to do is to now go to stat, okay? And remember, in your case, you would have to choose the option that is relevant to your calculator in that case, okay? So I'm going to say shift there. There's my calculation. Now, in my case, it gives me all the values, okay? So now I see that my mean, okay, for this class is going to be 71.4%. Okay, so that's for class A. So this is the mean for class A. Okay, so now you'd have to do the same for class B as well. Okay, just put in all those data points. By the way, just to note the standard deviation here. Okay, so there's my standard deviation there. It's 18.2, if we may put it that way. So 18.2%. This is for class A, right? That's my standard deviation. And of course, in your case, what you would have done is go back, just say shift stat again, press option 1. You see you've got X bar for your calculator there, and you'll get that, you've got the different options as I showed you. If you haven't seen that, please just go back a few steps in your in this video, and you'll be able to see that. Okay, so for class A, I've got my mean and I've got my standard deviation. Okay, right, now of course, now what we would do is we would need to do the same for class B. All right, remember again, so we're going to clear all the data there. And then I'm going to, remember we started at mode, you have chosen stat in that case. And what you may likely find is that, if you didn't clear all the data, you would still find it over there. All right, I went to stat, and then in this case, remember, I went to my one variable there. Now what I'm going to do is just simply replace that data. So I've got 65 for this class. I've got 67. Okay, so I'm putting in new data. I've got 88. All right, so I'm choosing to do this with you so that you'll see it. Okay, I've got 90, so I've got 88, I've got 90, and I've got 72 rather. Okay, let me just see, 65, 67, 88, 90, 72. Okay, and then we've got 67. Okay, so I'd have 67 there. Okay, and I'd have 75. Okay, and I'd have 48. I'd have 85. Okay, let's delete that. That's 85. And finally, I've got 57. Okay, right, now those are all my data values. So again, I go to my stat mode. And I will say, well, in this case, that would give me, those are all my values. So for class B, okay, so this is now for class B. Class B, it seems that my mean is also equal to 71.4. Please verify that on your calculator. Now, when I look at my standard deviation, okay, for class B, so for class B, I see that my standard deviation would be 12 point, let's say 12.9. Okay, so 12.9%. Okay, right, of course, if you wanted to find all the other values, you can still do that. In your case, you would have done that quite differently in your calculator. Okay, but I showed you that earlier on. Right, now look at this. So what can we say about the mean of each class, right? It seems like the mean in each class was exactly the same, right? Now, that wouldn't necessarily be a good indication of how the learners are doing in each class. So what does that mean now? Let's look at the standard deviation. So if you look at the standard deviation for class A, you see that class A has got a bigger standard deviation. What does that say? It means that in this case, if this was the mean for the class 18.2%, 71.4, you've got quite a number of data values that are somewhat far, from that mean, right? Whereas when you look at class B in this case, it means your data points are more or less concentrated around your mean. That's why you've got a smaller standard deviation over there. All right, now they say to us, calculate how many learners in class A. So we're looking at class A, have a percentage that is one standard deviation from the mean. Now, note that they said one standard deviation from the mean. They didn't tell us whether above or below the mean, right? So in this case, I'm going to take x, or rather, I'm going to take two values, x plus our standard deviation. Okay, I'm also going to take x minus our standard deviation. Okay, right. So if they had said above, as one standard deviation above the mean, so I would have said x plus only. I would have taken the x plus. If they had said one standard deviation below the mean, so in this case, I would have said x minus only. So I'm going to take the two values, okay? If they just say to us one standard deviation from the mean, in this case, it means either above or below. All right. So remember our mean value, 71.4. All right, plus in this case, for class A, our standard deviation was 18.2. Okay, so let's take that value. So that is going to be 89.6. Okay, so that's going to be 89.6%. Okay, so let's see. In class A, how many are above 89.6? Okay, I see there I've got 93, I've got 95, and I have got 89. No, that would not. Okay, so I've got 2, right? So I've got 2 values here, 2 learners over here that are above, okay, the standard deviation, so 2 learners. But now let's look at learners below the standard deviation. Okay, so that would be 71.4. Okay, and we are now subtracting. Okay, let's just make this a little bit more legible. Okay, so now we are subtracting, okay, 18.2. Okay, so that's minus 18.2. So what does that give us? Oh, I'm just too lazy to calculate that. 71.4 minus 18.2. Okay, that's 53.2. So that would be 53.2%, right? Now, how many learners are below 52%? Okay. So in this case, what we're going to do is we're going to look at, so let's see. So that's below 53.2. So I've got this one, 52% over there. Okay, and which other one? I've got 42 as well as 48. Those ones are below. All right. In this case, so that would mean that we've got an additional 3 learners, okay, that are below one standard deviation below the mean. So in this case, it means that I'm going to say, well, that's 3 learners over here. Okay, I hope I'm explaining this well enough for you to understand. So it means in total, the ones that are either above or below one standard deviation from the mean, in this case, that you've got a total of 5 learners. Okay, right. If they had said to us one standard deviation above the mean, of course, we would have only had 2 learners. If they had said one standard deviation below the mean, we would have had 3 learners in that case. So in total, the ones that are either above or beyond, that would have been 5 learners. I hope that makes sense, ladies and gents. So what I want us to do in the next one is just to take a past exam question so that we can see how to apply this principle. All right, now we look at our second example, right? We've taken this from the past exam question paper. And it simply says, according to an official in the quality assurance department of a manufacturing business, the standard deviation of a 340 milliliter can is 2.74 milliliters. And out of the sample of 20 cans, the following content was measured. Okay, so we've got all of that there. And then they say to you, determine the mean of the volume of 20 cans. Now, ladies and gents, you remember that if you want the mean, if you want to calculate it manually, what you'll do is you'll take all of those data points, take the sum of them. So you'd say 342 plus 338 plus 336, okay, 336, all the way up until the last value, which is 336. And then you divide by the number of data points that you have, which is 20, and you'll get a value around 338.6, okay? So that would be our mean in that case. But remember, we're going to do this through the calculator as well, right? And then to calculate the standard deviation, in this case, I got the standard deviation to be equal to, now remember, when you want to calculate it manually, the standard deviation would be the square root of the sum of, the data point, rather, not the mean, the data point minus the mean, right? But you square that, divided by n. Now this would be 20. So what you would do is that after you found the the mean, what you would do, so xi minus x. Now that's for you who for those who don't have calculators, but I would strongly advise that you use the calculator for this. This is quite tedious. So what you do is you would take your first value, which was 342, minus your mean, which was 338.6, all right? And then whatever difference that you get there, you square it, okay? You take that value, you don't square it first, you take the difference first. Once you find the difference, and then you'll take your next value, which was 338 minus the mean, 338.6, okay? So you keep taking all of those values, and then what you do is that you're going to take the square of those values, and you take the sum of the squares, and then you divide it by 20. But nonetheless, I mean, of course, you're going to do this through the calculator, right? Okay, so when I did it through the calculator, I cheated just a little bit. Okay, so I've already put in all my data values. There they are, 342, 338, all the way up until 336, the last one. And then I'm now finding, all right, the my answer there. Okay, so in this case, my final answer, okay, right, so there's my calculation right there, okay. I get 338.6 for my mean, as well as my standard deviation, in this case would be 2.71, right? So there's my value over there, right? So in this case, what I want to just simply do, okay, let's close that there. Right, so I found my mean, that's my mean there, x bar, that's going to be 338.6, 338.6, remember that's in milliliters, and then I found my standard deviation in this case to be 2.71 milliliters, right? So that means that this is, our standard deviation simply tells us by what margin, in this case, of error do we have in the data points, right? Now, the last question, they say to us, determine the percentage of data that is within. Now, please be very careful. When they say within, we simply mean within 1 standard deviation of the mean. So what I'm going to do is I'm going to get, now that's the difference between our previous example and this one here. They are saying within. So I'm going to say x bar plus my standard deviation, and I'm also going to have my mean minus subtract my standard deviation from it. Okay, so the first value there would be 338.6, okay, plus 2.71, and the other one is 338.6 minus 2.71. Now, let's try and find that value quickly. So 338.6 plus 2.71, I get a value of 341.31. Okay, so that's the value that I get. And for this one, if I say I'm subtracting, in this case I get a value of 335.89. Now remember, they said they wanted values that are within 1 standard deviation. So which means that if this is our data, this is our mean, okay? So I want values that are, so if this is our mean, which is 338.6, right? The one that is above is 341.31, and the one that is below the 1 standard deviation is 335.89. You can say 0.9. Okay, so I want values that are within those two values there, right? That are above 335.89, but that are less than 341. Okay, so how many values do we have there? So between 335, all right, so let me just write them down there. Okay, so we want values that are between, so that's 335.89 as well as 341. Okay, because when I scroll up, I just seem to forget. Okay, so help me in finding those values there. Okay, so the one that is above 338, in this case 0.89. Okay, so I see there I've got, okay, so I've got 340, that's the first one. Okay, another 340. I've got 338, no, 339, definitely. I've got another 340 there. I've got a 341, so that's less than 341.31. Okay, no, this one doesn't. Okay, that's another 340 there. Okay, 336, nope. 342, nope. 340, we've got another one there. All right, so how many values do I find that are within 1 standard deviation? So it means that my lower boundary would be 338.89. My upper boundary would be 341.31. So that we were looking for values that are within these two. And so how many did we find? 1, 2, 3, 4, 5, 6, 7. So in this case, it means that we've got 7 data points. Okay. They said determine the percentage of the data. So in this case, remember, so if I want it in percentage form, so it means it's 7 out of 20 multiplied by 100. Okay. So so just for you to keep in mind, that's going to give us 35%. Okay, so it means that 35% of our data is actually within 1 standard deviation from the mean. Okay, right, I hope that was clear. Ladies and gents, I think this is it. Okay, All right, thank you for watching, and please don't forget to subscribe to our channel, of course, and take advantage of those wonderful playlists there, that your favorite uncle has tried to compile for you. You've got all the videos that you need in physics and in mathematics. So in preparation for your prelims, also just make sure that you just watch as many of them as you possibly can so that you do well. Please don't forget to hit that subscribe button. We want to get to 100,000 by this year. So not just for the sake of it, but for the sake of helping you to thrive in mathematics and physical science. And by the way, you can visit our website. Okay, so our website is www.mlungisiNkosi.co.za. And by the way, take advantage of, we've also got past exam question papers there. When you just navigate in exam paper there, you can go and search for the title of the paper, whether it's maths or science, and just see to it that you take advantage of those question papers and download them, and you can use them as much as you want. All right, and from me, your favorite uncle, thank you so much. All right, so I hope that you were able to enjoy that lesson. From me, your favorite uncle, I'll be seeing you guys again next time. And please just be sure to, hit that subscribe button if you haven't already. And please share and like and tell as many people as you possibly can. Otherwise, from me for now, I'll see you guys next time. Sharp, sharp.